Okay, good evening everyone. Hopefully we'll start the meeting now. Welcome everyone. Not the best weather outside, so I'm glad you all turned up. Just like to say that our Paul, our battery guru back there, and all-round organising type person, has had a little accident, but still was able to hobble in, which is great. So, bitten by his EV. Well, in fact, it was an ICE that came in and ruined his day and totaled his Vectrix. But it will be rebuilt, although in a different colour, different form, same sturdy batteries. So let's start the meeting. Just let everyone know that PIP, Australian Permaculture Magazine, would like to do an article on EVs, especially on conversions and how the conversion process compares to petrol cars, and doing a little bit of a cost comparison, that sort of thing there. So if anyone's interested in being interviewed and being world famous in a permaculture magazine, then please speak to me and I will pass on Robin's contact to you. It should be, you know, if you've got an EV that's up and running and got some EV experience on conversions, then it'd be great to speak to Robin at the Permaculture Magazine and spread that information and keep popularising EVs. Also, just of late, if anyone saw the checkout recently, they had a spot on whether EVs are green, and their conclusion was not in Victoria, not if you're buying coal electricity. So for those that get onto iView and those sort of get onto the iView site, you can have a look at that checkout episode. Also, is Rob from MindDrive here?
He's in the US tomorrow.
Right, he's already popped over. Yeah, well, Rob is over. He's with a MindDrive project, which is where we get where at-risk kids are put on a project to build an EV and then drive it around. He's over in the States at the moment. Going to do a drive across the country in an EV. So hopefully we'll hear a bit of a report back when he's back here in Oz. And also I'd just like to let you know that that in the coming month there's going to be an Around the Garages in Geelong. And so if anyone is interested in going to Geelong, we'll do a bit of carpooling for that, so that we can see what some of the guys over in Geelong EV group are doing as far as their conversions on some of the vehicles they're working on. So that should be a good little outing, and hopefully the weather's nice, or at least bearable. So we'll send out an email about that when I can confirm the date when that's happening, but that'll be happening in June. So June's not far away, just a few days. Hopefully it's not on the 1st of June or something. That would be not so good, but it'll be on a weekend during June. So we'll send out an email confirming that, and hopefully we'll get some carpooling together and go off there for a jolly little jaunt over to Geelong, home of the unemployed. Now, any past events that people know of that are worth letting us know? Not so many events, I see. It's a bit not the weather for it. Also, any future events? Anyone know of any future events coming up besides the Around the Garages? No? All right. Ooh, yeah.
Its Pikes Peak will be coming up in the US very soon. And then last year at Pikes Peak, electric motorbike was one of the American ones, won Pikes Peak's competition against the factory Ducati and Yamaha teams, and they won by 20 seconds. So it was a very convincing win. So it'll be interesting to see what happens this year on that with Pikes Peak's competition.
That's a long, arduous hill climb, isn't it?
It is, yes. Yes, a very long hill climb.
Oh, well, that'd be good to see some news on that. So if anyone comes across anything on the interwebs about that, if you want to post it to the ATA EV Group Melbourne Facebook page, that would be fantastic. We can see a bit more about that. What else have I forgotten? Oh, yes. Anyone doing anything in their garages at the moment?
Trying to clean it.
Very good. Using anything electrical in there? Souping up your vacuum cleaner? All right, cool. All right, well, I might just get on with the business end of the meeting now. We've got this. Oh, yes, yes. There's one more thing is that I want to support the cause. So come and get your fossil fuels is for dinosaurs T-shirts. Come and get them. They're red hot. Get them while they last. We have them here, and you can go for a tenner. So if you're feeling a bit cold now, there's another T-shirt to put on before you go outside. So for a tenner, save yourself from hypothermia. So grab one for yourself, one for a friend. Fantastic. Yes. Then now we've got the SolarX solar hybrid sports car team, supported by Aurora solar car team and Swinburne Uni Mechanical Engineering, as seen in the ATA's Renew magazine. Oh, there we go. If I'll get one for the camera. So here's the Renew magazine for those people out there in Webland. And we're selling them here. You get them cheaper here than you will anywhere else. So again, don't buy one, buy two, buy three. And all the money goes to our lovely little group here to keep us running and all operational. So the SolarX mob, they've got a prototype or a concept car called the Survivor. We're going to hear a lot about that in the next little while. There's going to be 9 speakers. I won't be asking you to remember all their names, but I will ask you if we can keep questions to an absolute minimum after each speaker, like 5 minutes of questions tops, just so that we can go through, and there'll be a chance to speak with everyone after when we go and do the social side of things after the meeting. So who's going to be first up? It's Clint Steele, Swinburne guru and all-round nice guy, will kick off the proceedings. And so make him welcome.
Okay, so as Dean said, you want me over here, dear? Oh, yeah. As Dean said, we're looking at the development of a solar car, not just a solar car in general, but a solar car that's actually suitable for road conditions and is also, well, suitable for road registration, I should say, and is also commercially viable. That's the main goal, what we're looking at. What I'm going to do tonight is I'll first go over the history and how the project came to be, and that's just to set some context so you actually know when you're looking at some of the things later on, you understand why we're going down a certain path. Because when you understand the history, you probably have a better understanding of why we're doing some of the things that we're actually doing. We're then going to take a look at the technical aspects, and that's where we're going to break down into each section. And we're not going to give so much an overview of the whole car, because I'm assuming most people here basically know how a solar car works. You've got solar panels that power the batteries that then powers the motors that drives the car along. So instead what we're going to do is we're going to have each team member drill down a little bit more deeply in their particular area. They're going to talk about the challenges that they faced that were unique to a solar car, because I figure that most people here know a bit about cars, and you probably also know a bit about electric cars. What will be of greater interest is what's sort of particular and what's difficult about a solar car. So each person is going to talk about that with respect to their particular section. Then they're going to talk about the ideas they came up with to overcome those problems, and then they're going to talk about those actual solutions. So to give you an idea on what problems we faced, how we went about solving them, and what the car's probably going to be looking like in the future, because I figured that's what you guys are mostly interested in. And then at the end, we'll actually get Barry Nguyen from SolarX to wrap up with the business model, and that's to actually explain how we're going to make it fully sustainable. So not just environmentally sustainable, but actually commercially sustainable, so that we can actually produce these things, have them on the road, and nobody can actually say it's a charity case or anything like that. It's actually very sustainable transportation holding its own in the commercial world. So that's just to give you an overview of what's going on. I'm going to go over the history myself. Like Dean was saying, at each section we'll have just a period for some questions, because I figure there's 9 people, we can't remember everything that was said, just to go over those urgent questions, but then at the end we can have a more in-depth conversation. So, project history. What we've noticed is that the interest in solar cars has been dropping. This is a graph from Google Trends. If you never use it, I think it's just trends.google.com. And what you can do is you can type in a search word and it will give you the history for past roughly 10 years now on how frequently particular search terms have been searched. So anything you're interested in, you just see like how popularity changes with time and things like that. And so this should be a search simply for solar car. And you'll see that there are peaks, and those peaks are basically, so we've got, I'm talking about these regular peaks that come roughly every 2 years. That's the World Solar Challenge. That's the race from Darwin to Adelaide. So every time the World Solar Challenge is on, people are more interested in cars, or in solar cars. However, you will see that those peaks are dropping considerably each time. You could argue that maybe the World Solar Challenge organization isn't doing as good a job, but I think what's happened is that really the novelty is wearing off. At first, people were just amazed that you could get a solar car from Darwin to Adelaide, and not everybody made it, but now the team is doing quite well. I can actually remember when I was a kid, they actually made a kids movie about an American team, a high school team, who was going in the race, and they used to get on the news and things like that. Last year was an event, very few people even realised that. So what we're seeing is that the World Solar Challenge isn't having that same punch that it used to have in telling the rest of the world what solar power can actually do. And so something had to be done to deal with that, and that came from Aurora, and the then chairman, David Fuchuk. He called for the development of a new, what he called a truly zero emissions vehicle. It was going to be coming from Aurora. So for those of you who don't know, Aurora is essentially the premier solar car racing team in Australia. They're very well regarded around the world. James is a member, for those who don't know. Have we got other members here? I probably just can't recall, but you guys won your division. Aurora won their division last year. So they're a very well regarded solar car racing team, and they were the ones that put forward that idea of having a solar car that could actually go on the road. In 2010, Ali Jafari, who was a part of Aurora, came up with a concept. I can't remember exactly what it was, but the concept won a few awards and it started getting a bit of traction. After that, Aurora and Swinburne, we officially partnered to engineer and build a proof of concept prototype. So what happened at that stage, Aurora they had the idea. It needed, I guess, a few more members that were going to do the grunt work. A lot of experience in Aurora. They've been in the game for like decades now, so they know how to build a solar race car. But what we need is when you get to that stage of commercialization, you really need to take the design to that level of refinement and documentation, because you can't just build it and then race it. You want to produce car upon car upon car, which means you've got to use a little bit more established engineering discipline to be able to document that and know that it's something that can be made not just by yourself, perhaps by other people. You can't just sort of craft it for that one race. You've got to have something that can actually be produced again and again and again. And that was where Swinburne engineering students were an ideal fit. So that was all good to design it, but then the issue came of actually commercializing it. And then last year it was when Barry Nguyen approached Swinburne looking basically for anything in the EV space because that was his interest. And then we came across the solar car project. Barry's now jumped on board and he started up SolarX specifically with the intent of generating the funds to commercialize this vehicle and also just related technology and other vehicles in the space. So that's to give you some context. Any questions about that at this stage? I figure that was just setting the scene, so you'll probably get more questions from who's coming up next. So next is Davis Tolley. He's a product design engineering student, and he's the last guy who's been working on the body design. Quite a few people have, but he's the one that's really taken it home. So I'll pass over to Davis now.
So I'm going to speak briefly about the three major challenges we've had in designing this vehicle. The first one is aerodynamics. Obviously, aerodynamics is really important for a vehicle's range, especially at higher speeds. So aerodynamics have a big effect on the final range of the vehicle itself. Another issue has been solar panel mounting. How do we actually mount a large number of solar panels onto a standard-sized sort of car? And the other thing is aesthetics. Because of the aerodynamic constraints and the solar panels, it's kind of hard to make this vehicle look like a car at all. So that's been a tricky element as well. So just getting an idea of what sort of cars are out there in terms of aerodynamics. To enable our concept to be viable, we've needed to achieve a CDA of 0.2. CDA is a measure of aerodynamic performance independent of the vehicle's speed. So it's a good way of comparing different vehicles and how low their drag is. So these are two of the lowest drag vehicles I was able to find that have been commercially produced and are also road legal. So as you can see, both of them have much higher drag coefficients than what we're trying to achieve. And you also notice, especially with the top one, that the aerodynamics are starting to impede on the actual look and shape of the vehicle. So this is where one of the major challenges have come from. And just to give you more context, your standard Hummer or SUV has about 12 times the drag that we're trying to achieve. So our target of a CDO of 0.2, we've managed to achieve that with our latest body design. We've mostly been using CFD at this stage to analyze our vehicle's aerodynamic performance. Mostly we've been using ANSYS and some of the software that comes with that.
You need to explain the acronyms.
Okay, so ANSYS is a multi-physics simulation program, I guess you'd say. So we've been using an element of that called CFX, which you use to basically set up a scenario, and you model the air flowing through that scenario, and you put the body of the car in that area, and it's able to tell you things about the aerodynamic performance of the vehicle. So we've been using that quite heavily at this stage. So at the bottom, that's our current vehicle design, and you can see the streamlines running over the vehicle. You probably noticed that they're really smooth, they're not turbulent or anything like that, and that basically means that the aerodynamics are good, I guess you'd say. So our next major area of concern is solar panel mounting. To make this a viable car, we really need to achieve a minimum of 5 meters squared solar panel area, and that's not just a small amount of solar panels. That's almost as many as the car on the right-hand side there, the Aurora Evolution, which has 4.8, just over 5.8 meters squared of solar panels. So as you can see, the solar panels are really going to impede on the look of the car, as well as the design in general. So some of the other issues we've had and things we've had to overcome. Cabin size is the main one. If we go back to the previous slide, you see that in this vehicle the cabin is really small. That's to enable not only more solar panels to be mounted to the roof of the vehicle, but also to reduce the front surface area, which reduces drag. We've actually opted for a slightly different approach to solve this problem. What we've done is we've actually widened the passenger compartment, and we've mounted the panels on top of the passenger compartment instead of the sides. And this has enabled us to get a much larger passenger area while still having the same amount of solar panels mounted on top of it. Another issue is ingress and egress, or how you actually get in and out of this car. For such a light car, traditional doors really aren't viable because they're quite heavy, they're complex, and also they reduce the structural rigidity of the side of the vehicle. So we've opted for a slightly different approach. We're actually going to have the canopy of the vehicle lift up and forward with a 4-bar linkage system. This enables us to have only one set of locking mechanisms, one major hinge, all that sort of thing. So it just makes the vehicle lighter overall. Another issue is overall size. As you saw with that previous vehicle, it's really large, and that's just not viable for a passenger car. Initially, the vehicle was about 5 meters long and 2.2 meters wide, which is would be quite clumsy to say the least. But recently, we've managed to bring that size right down. So now the vehicle is about 4.5 meters long and about 2 meters wide. And the other thing is styling, which I've already mentioned. To get the aerodynamic targets that we wanted, to start with, we had to shroud the wheels completely, so completely enclose them in within the body. This has actually been really bad for the aesthetics of the vehicle because the appearance of the tyres actually has a large effect on how the vehicle looks, and without being able to actually see tyres there, the vehicle kind of just looks like a blob. So we actually had to put coloured areas which represent tyres, which kind of make it look a lot more like a car, basically. And so that's basically, and so these are our concepts. So these were our initial concepts from the past year or so. This is one of our first ones. The problem with this one was mainly aerodynamics. And so we did a lot of tweaking and came to this design, which was kind of completely different. This enabled us to meet the aerodynamic requirements and also the solar panel mounting requirements in terms of area. One problem with this design was the fact that the solar panels are mounted quite low on the body compared to the canopy, so you actually get shading. The canopy will shade the solar panels during different parts of the day. Seems pretty obvious. So then we've come to our latest design over there, which has the panels only mounted on the roof of the vehicle, and there's no panels on the side. This has also enabled us to widen the interior cabin even more, which has been, which is good, obviously. And overall, we've gone through about 300 different CAD models and close to that many different concepts to get to this stage. But it looks like we've been able to meet all the targets that we needed to, so that's good. So that's cool.
Any questions? I assume to get a reasonable turning circuit, the steering wheel's got to be inboard a lot more than normal.
Yep, and that's what we had to do with the wheels. That's why the body was so wide, because you had to completely shroud the wheels, and then you had the width of the wheel actually turning inside the shroud. So that's one of the problems we had with the size of the vehicle.
You couldn't have the shrouds to the wheels?
You could, but yeah, but then you have them. They have to move independent of the suspension, obviously. So you need a separate control system to have them move, which would be bad for weight, obviously. And also when they open up and the car's traveling at moderately high speed, you get air flowing into the vehicle.
Are those see-through solar panels?
Where's that? Sorry.
On the latest design, it doesn't look like there's a rear view mirror or
Rear window.
a rear window.
There isn't. So we're using cameras inside the vehicle for rear view and also side view mirrors as well.
So is that legal under Vic roads as a?
I didn't actually look into that, but I assume so. That wasn't my job. So I'm told it is.
We did look into it
Oh,
originally, and it was legal. Yes.
We're hoping it is.
This was like the idea was given to us by us engineer.
Oh.
It is, yeah. As long as there's, you know how we have 3 mirrors normally? As long as there's at least 2 of those visions, it's fine. It passes.
Right.
Yeah, it's a common capacity.
No, we're not Monash, mate.
What's that?
Oh, we're not Monash. No, that's what you think.
Is the third comparison just to the coefficient of drag and not the front area as well?
So those measurements, they were the coefficient of drag area, not the coefficient of drag. So that does take into account the front surface area. Yeah.
The chassis design, is that a new design from ground up, or you're using something that's already been tested in terms of
I'll be talking about
Dual skills.
Wasn't sure. I'll ask you the question.
Okay.
Cool. Thanks.
Thank you.
Hello, my name is Alice. Thank you for coming. I'm
designing the interior. So I was given the interior, there were specific challenges to designing it in regard to a solar car. Obviously, we want to reduce the drag, and the reason why we want to reduce the drag is so that it makes it more efficient. And what comes with that is also we want it to be more lightweight. If it's more lightweight, we're not using battery that we're not necessarily requiring. And also it means that the car can last longer. And also one of the things was, because it needs to consume less energy, we couldn't have an air conditioning system because it uses a lot of energy. So we had to sort of figure out what ways can we cool the passenger without, you know, using so much energy. So we had to tackle that as well. And also aerodynamics, trying to complement what's happening with the body, and also being able to adjust with different body sizes, sitting in the cabin without using drastic, like, you know, in your seat you've got levers and things to adjust, but that's all weight that we cannot afford to put in this car because of the low energy consumption requirements for it. So this is the interior. Obviously it was meant to complement the aesthetic of the body, and a few features that were put in were to help it being lightweight. This panel here is actually not a panel, it is a piece of fabric. It's sort of like a skin covering what is underneath as the glove box area and then this dash panel area. So this is one module, and then there's supports within the chassis that support the fabric, and that becomes a skin helping us reduce weight. So that's what's underneath, and so it's designed so that it's modular, so that if in any case you want to design this car for left steer, we can move this, rearrange the structure below it, and then that will be fine. And also the panels, the control panels are very easy to adjust and customize for different people wanting different features on their car. Yeah. So this is the seat. The strategy to cooling the person without using as much energy is to flow air directly into specific locations of the body that help people cool themselves. So the major, this came about from research from spot cooling. Spot cooling in the area between the neck, under the arms, and between the legs is what's found to be most effective. So inbuilt in the seat, can't really see that, it's a bit dark, but there's channels at the back of the seat that allow air to go through to those locations. Those channels also help rigidify the seat, so that it means there's less material in the seat that you need to still support the person. So it's a lightweight juggling act with it. And also the foam, these pieces here, they're foam components. What they're designed to do is you know, allow breathing space for the body to just disperse heat, and also customability of the foam components to adjust for different users. They're foam components that they've got Velcro on the back. You take them off, you can put it in the wash if you feel like you need to. Sometimes your car gets a bit filthy, and it's, you know, it's good to be able to wash. And also you can customize colors and skins for different users. So that's the seat. This is, yeah, just breaking down what the seat, the foam components in there. The carbon fiber seat made from 2 layers, simple 2 molds that combine together. First mold made, and then the second one gets layered on top, just to create the channels within the seat for the breathing of the flowing of the air. So that's the interior in a nutshell. Any questions?
I've noticed you incorporated a steering wheel.
Yes, I have incorporated a steering wheel. Very helpful to steer a car. With airbag, no. Unfortunately, it's not a requirement. The requirement is to stop head impact within 8 Gs, and there's other ways of tackling that, and we haven't gone the airbag direction because it is a very heavy system. So,
Alice, that wasn't replacing the mirrors meant to do with your screen.
Yeah, sorry.
That's it.
I didn't mention that, yeah. So in that first picture, there are screens on the side. So these are screens. We've got little review cameras on the side of the car, and that's what's shown on these display screens.
But they're actually inside the car.
Yeah, they're inside the car. The reason why it's done like this is because you can show it's inside the car's quite wide, and so there was some point where it sort of drops down and then it gets you the space for those.
You actually got them pretty wide. Why would you put them just each side of the steering wheel sort of thing?
Next to the steering wheel.
Like each just.
Well, the intention was to put them where people associate where rearview vision is, so that you go, that's my left, that's my right. If it gets too close, it may. I mean, it's a personal thing. I think it depends on the user. But yeah, that was the intention, to make it as familiar for the average person to understand and feel comfortable driving it.
How do you get your airflow from cooling the seat?
The cooling goes through the chassis. So yeah, the chassis that facilitates where the airflow comes from. It's from the front of the car and it goes to the back. Yeah.
What about heating?
Heating.
Good question.
Yeah, that is a good question. Yeah, we're thinking more of cooling because of the strategy with the Solar World Challenge being all about getting too hot, and so it's more about finding a way to cool the person down. If it's too cold, you can always just close up the vents and you're
Put it on a coat.
Yeah, put it on a coat. So more environmentally friendly. Yeah. That's it.
Thanks, Alice. Hi, so I'm Caleb Foster, and I'm the student engineer behind regenerative suspension. So, yeah. So initially I was tasked with a feasibility study, researching potential existing patents and existing designs for regenerative suspension. And given the average car only puts about 10% of the energy from the fuel tank to the road, it's a pretty competitive field. So during my research, I noticed several trends. They're all heavy. They're all quite large systems, and most of them are in several components. And given our sort of car is going for hyper endurance and slow weights, none of these systems are really quite suited. So one of our initial goals was to make a combination electromagnetic and regenerative suspension system. The second goal was, of course, to be able to integrate seamlessly into our high voltage system. Overall, we want to raise the efficiency, and we want to, most importantly, reduce range anxiety. So the problem with the current hybrids is, of course, that they've got such a limited range that the user has to be constantly mindful of the amount of available charge left. So this will help contribute to that. And we want it to be a semi-active damper. So what we want to be able to passively act as a shock absorber, but we may be able to control that in future iterations. So during our research and design, the major issues were the power and weight ratio. As I said, it's a hyper-endurance car. Every kilogram matters. And of course, with that comes the form factor and sizing. We want this to be as modular and adaptable as possible. However, we also want to be adaptable to our vehicle and potentially others. The power output, of course, we want to be a usable power output. In this case, looking at making it AC to be as compatible across the board as possible. And of course, we want to achieve the required damping. The hurdles during this were the form factor. Given we're trying to squeeze a fair amount of electronics into such a small space, it becomes a bit of a hassle. Weight was constantly a factor, as well as limited space, which I said. And because we're dealing with high voltage and magnetism, the materials, of course, were of concern. Any metal in close vicinity to the unit could possibly offset the magnetic circuit as such, reduce efficiency. So here's the current iteration, and the hand crank model over there works the same way, which one of our members had an unfortunate experience before.
Sorry.
So far, we've got running at about 3 to 6 phase AC. during optimum conditions, we are achieving a range of 22 to 46 volts. Given a shock absorber can go anywhere between 50 hertz and 3000 hertz, we've got quite a wide range. And yeah, at best, it currently produces around 22 watts, which is usable. It's not as much as we would like, so future iterations we would like to try and raise up a bit more. Mechanically, of course, what sets this unit apart is because it's purely magnetic, there's no hydraulic and there's no transmission systems involved, and as such, the unit's quite light. We made it out of an aluminium composite design, so it's rated to max, because it's shock absorber, we would need to expect it to act as shock absorber and handle anything shown at it. So yeah, it's designed to handle up to 15 kilonewtons, which is a tire hitting a curb quite high speed. So yeah, questions?
How much, like you were saying, that you'd like to see more wattage output from it? How much do you think is still available in the cars? Obviously, got to be going up and down on bumps or something like that that you're not getting.
Yeah. Best estimates I can get around about 60 watts during like the calculation. Of course, getting it physically is a bit of a different story, but you know, it's all the design process. So.
I think 22 watts or even 60 watts is worse than trouble.
Well, when you're considering it's 22 watts per unit.
So there's one on each wheel.
Oh yes, of course, yeah. You know, with a car like this, efficiency is everything. So anything we can do to help get a little bit more range in it would be, you know, usable. But of course, the beauty of the design is it's completely modular and it can adapt to quite a range of vehicles, and/or it can attach to civil structures or something like that to in a similar fashion. So, yeah.
Is it feasible, or did you look at having two various magnets opposing each other instead of a spring? Like two more poles or whatever?
That was one about future design iterations we're looking at, yeah.
Be lighter than a spring or heavier.
This is a bit of an older render, but yeah, I didn't have time to do the renders. But yes, magnetic springs would be a viable option to help reduce weight. However, when you're looking at 15 kilonewtons to stop it, the magnets are quite large, so they're about 3 kilos a piece, which, you know, already outweighs the entire unit itself. So that's where it sort of becomes a bit of a hassle.
What's the weight of the lot of a comparable conventional shock absorber?
Good question. I'm not certain. Do you help out here?
Your standard shock absorber, probably looking at about 1.5 to 2 kilos.
Okay.
That light?
Yeah, they're actually quite. They're pretty light. That's just the shock absorber itself. Not this isn't including the springs, but yeah.
So comparable.
No.
Anyone else? Yes.
The 22 watts there, is that peak? Is there some sort of low profile at an average?
We're working on that. These are sort of tested at extreme ends of the spectrum. So it's sort of like this is a prototype I produced during the design phase. So like I'm still trying to refine it, and then we'll sort of start to get a proper characteristic curve of its output and its behaviour.
Presumably, this is something you can easily carry on to a normal vehicle.
Yeah, of course. Yeah.
Like, isn't such a big factor on a normal vehicle.
Yeah, and given how light it is, and the existing systems use, as I said, hydraulics and/or transmissions, given this is purely electric, it is quite light, and as a result, it's quite adaptable to many applications. So, yeah.
Are you having one per wheel, or is it like a double wishbone setup with the shocks?
I was making a unit. It's up to the suspension guys, but at this stage, it's roughly one per wheel. So, yeah. Anything else? That's sort of one of the ways. That's what we're using to help assist it. Actually, yes. One of the advantages is that we can actually, as I mentioned, it was 3 or 6 phase. We can individualize each portion of the regenerative shock absorber, and then passively feed back energy to stiffen up the suspension or soften it. So yeah, it's quite modular, I suppose. Anything else? We're good? Yeah. Oh, there we go.
Hi, my name's James. I get to talk about the boring mechanical rear suspension. Just going to talk briefly because there's not too much sort of electronics. I know you're more of an electronics-based sort of organisation.
We do it all.
Some of the major issues we faced with the suspension was having a large amount of unsprung weight when comparable to the rest of the weight of the vehicle. We're talking very sort of low mass vehicles, around 500 kilos fully laden. And with the in-hub motors we're looking to have, they're about 19 to 20 kilos each, and we're having 2 of those at the rear of the wheel. So you can see that that's quite a significant factor. Other things are like the general weight of the system and the complexity of the system. So the more complex you get, the more components you add, the weight just increases. More weight is reduced range for the customers of the car. And the actual mounting and support of these in-hub motors has been quite a challenge. It's pretty much however you do it. Because of the large weight of the motors, it causes all kinds of stresses and problems, especially dynamically as the car's moving along and hits potholes and everything. Some solutions we sort of looked at were using very lightweight materials, so the carbon fibers, titaniums, those kind of things. We thought the best way to achieve all the dynamic constraints, especially with geometry, was to use a beam axle design with 4 linkages to try and restrain it. And to overcome the motor mounting problem, we actually have a bit of a hoop that goes around the outside of the motor to support it from both sides, so that there aren't too many stresses transmitted through the motor, which can damage the motor and reduce your efficiency.
So inboard mounting with a carbon fibre axle, was that the question?
I'll cover
that. So this is sort of one of our latest sort of iterations of our suspension. So this is basically to show the general sort of geometry that we're going for, and this is sort of how we feel will meet all of our targets and requirements for our car. And that's basically all I have to say. So is there any more questions? No.
Hello everyone, my name is Joe. I'm working on the chassis. I'll talk to you about the chassis first. Major issues. We had to make this car as stiff as possible to pass all our ADR requirements and just for general performance. We wanted to make it as light as possible, and seeing as it's the main bulk of the car, that's pretty crucial. Weight distribution was also a factor, as well as customization for the international market. So we've gone with the monocoque design, as shown right there, and it will fit in perfectly with the body of the car, as shown there. So we're using a carbon fiber foam sandwich composite. We're still researching into which exact foams and the like layup and ratios of foam to fiber and resin and whatnot. I had to, for the weight distribution and the weight of the car, I've integrated the ventilation, interior, and the body into the actual design. And most of the major masses, so people and the batteries. So people, we've been using for the weight distribution roughly 200 kilo people, and we've got, I think it was 60 kilos of batteries, roughly. So we're trying to get them as close to 50-50 distribution as possible in the car. And the front has been made symmetrical, so you can change the steering from right-hand drive to left-hand drive and vice versa. So this is what it looks like combined with the body. This front section here is the door that Davis was talking about earlier, and it will be the glass and the A-arms and everything that will rise up. The crash structure, which we don't have anybody to talk about this right now, but the ventilation actually goes through the crash structure and into the chassis, and travels through these channels in the chassis. They take it to the back of the chairs, and that delivers the spot cooling Alice was talking about earlier. This is a rough design so far. The dash will mount onto this section here, probably isn't us. And we've got a center console which the batteries will slide into. We're trying to think of a rail system or something to make the batteries relatively easy to get out. The steering will go into this section here and can be changed left or right depending on the driver. With the suspension mounting to these outer walls here inside. I've been talking with Davis about body mounting as well. So the front section will actually be a nose cone that sort of bolts on, and it'll have the crash protection in there. The wheel covers, they can come off separately to change the wheels and also to get to the pins to take off the front. The back is still being worked on, but it's going to be 2 or 3 pieces.
So we would ask the same question again with the back design. Why
Sorry?
we can go for inboard motors with, say, carbon fibre drive shafts?
Once again,
and
sorry.
also-
Drive. This man's the drivetrain man.
I'll go through that.
Yeah. But just for when he does talk about the drivetrain, one of our issues was the back in terms of the actual curve that Davis had to put into the body is actually quite steep and kind of limited the movement of the suspension in there, so we had to think about that as well. Trying to think of what else I had to talk about.
How much ground clearance?
Davis?
Just above 80 yards, so 110 mil at the most.
Which would be those wheel spats here. The center of the car actually rises up a bit more. Yeah. Does anybody have any more questions?
What sort of weights are you looking for to try and achieve different chassis sections?
So it's all going to be roughly 3 or 4 moles, and we're trying to get it to. We have a weight budget of about, including the interior and the front crash structure and the side impact. It was supposed to be a rough weight of about 100 and I think it was 100 kilos. Currently, I'm at about 150, but that's a very rough estimate as I've been working with rough densities to figure out the weight because we haven't yet figured out exactly the composition of the material that we're going to use. And the foam, we'll be using different types of foam and different ratios of carbon to foam and whatnot at different areas depending on where the stress concentrators are and stuff like that. So yeah, we're going to...
That would be a big part of the design, isn't it? So
yeah.
Get the structural integrity.
Basically.
The stress points and those enforced, those are meant to get into the weight budget.
Yeah, and we're working on an Excel spreadsheet now to work out.
Having a roof that's not,
yeah,
means you're going to have extra strength in other places, maybe extra weight. Yeah. That could counteract the fact that you're saving on weight and having
Sorry. Can you repeat that question?
For instance, if you have a convertible car that weighs more than a regular car, does that stiffen the chassis? Okay. By putting the roof in, they take weight out of the chassis and get the same rigidity. So adding a few doors and hinges isn't adding as much weight as stiffening the chassis.
It was also a matter of sealing up those doors.
It's got more to do with that.
And the side impact as well.
Yeah, the side impact in as well. So as soon as you introduce doors, you need to start meeting side impact door ADRs, and those ADRs themselves actually increase the weight dramatically.
Mainly due to the door being a weak point in the chassis as well.
Like a half door or something, because you're actually going to find out over the side.
It's actually not that high. Yeah. It's actually not that high. It's about mid-thigh height. So it's relatively easy to get in and out.
Sports cars aren't meant to be easy to get out in and out.
Yeah, exactly. Any other questions about the chassis?
The vehicle's supposed to be used in the road use, right?
Yep.
But that's speed maps, you can't even use it too.
That would be a factor. The actual ADR was 100 millimeters.
Isn't it? It's 4 inches, I think.
100 millimeters roughly.
Yeah, so
we're just above that, but yeah, it would be more dependent on the actual suspension to keep that under that height. Yeah. Any other questions? Yes.
How are you doing all the analysis of the string?
We're using an Excel model to analytically analyze it. numerically analyze it. And we're also using ANSYS to run tests on it. Eventually, once we figure out a material, we're going to be running some actual physical tests on the material to determine if it's strong enough for and suitable enough for the car, the chassis.
You're actually putting a composite into ANSYS.
We're currently trying to actually figure out, using Excel, we're trying to find the closest material properties, physical and mechanical properties of the materials, so that we can then plug it into ANSYS. Yep.
Have you looked at any other materials besides carbon fibre foam sandwiches?
Yes. Originally, we were going full carbon fibre. Before that, we were going fusions of carbon fibre and some aluminium rails. We had troubles with thermal expansion. And overall, this was going to be the lightest solution, given our quite severe weight constraints. Any other questions?
Actually, one trivial one. If this is a solar car, it's got to be in the sun quite a lot, one imagines.
Yeah.
And plastics in general degrade in the sun. I'm not sure whether the materials are particularly robust, but is that a consideration?
It is actually a consideration. I'll actually talk about it in the next section a bit as well. May as well just go straight into it. I'm also, as my project, looking into the encapsulation of solar panels. So these panels are going to be on the outside, and we're looking at, I've only just recently started this in the last couple of months. We're looking at different polymers and fiber and composites to actually encase these panels to keep them strong, to reduce UV degradation, to reduce heat degradation, and also so that to increase the life of the actual body of the car. As they'll be on the outside, they'll be subjected to everything the weather can throw at them, people sitting on them, stuff just flying up at them. So yeah, we're trying to do this as we're trying to keep the traditionally panels for the Aurora car, for example, they kept the weight low by not really having much in the way of encapsulation around it. So if those panels were to be used in real world conditions, like as a passenger car, they would degrade quite quickly. So we're looking at materials that will stop, like try and block out UV spectrum and above, as that is the spectrum that actually degrades these monocrystalline cells that we're planning on using. We're also looking at polymers that won't melt under the sunlight, they won't degrade and stuff like that. Currently, however, I've only just started this in the last couple of months, so I don't have too much detail yet.
You're looking at monos, not polycrystalline?
These are the cells that are supplied for us. They're actually the SunPower monocrystalline cells, and they're, I think it was 22% efficient. So they're actually quite high efficiency cells. In terms of the actual encapsulation and keeping them safe, I prefer thin film cells because they're quite a bit easier. But I've got to work with what we have. So, any questions? Any other questions?
The inboard motors going to want this.
Well, yeah, the inboard motors did work well for unsprung mass. And overall mass, though, they do increase. So those are things that we still need to take into consideration with further analysis of suspension, chassis, any extra chassis mounting, aerodynamic body changes, and in general, reliability, efficiency, even ease of changing the tyre. Some of these things make it harder to change the tyre.
Even mounting your motor still over the universal joint.
Yep.
And the motor moves with a Volkswagen shaft, so there's no universal joints at all.
Yeah, and that's
just a solid shaft.
That's what we're going with the EDIF. So 2 motors centrally mounted, and they'd move. Yep, they'd pivot with the wheels, but given that they're so far inboard, the movement will be minimal. But then we have unsprung mass. Well, it's still.
It's moved a long way from that.
Yep. It has moved, yeah, sorry, yes, it has moved further in, so the moment is now smaller. that's all my part, but are there any questions? Yes.
One of the issues you considered copping the 8 kilos of brakes or something on the back. Like, how does that relate to those? If you're only should you just add 8 kilos of brakes?
Yep. So by changing the way that we got the drive, we can actually select different motors. There's also motor flexibility, so we can get something that's bigger, but will ultimately weigh less than 2 of the CSIRO motors, which are about 19 kilos each, plus their controllers and everything. By going to one motor, we can move to something that could be heavier than just one of those motors, but still lighter than the both of them. Adding the weights through a diff is still less than what we've roughly calculated than adding more brakes on the back. Yeah.
Could you utilise some part of your motor as a stator of the brake?
Sorry?
Could you utilise some part of your motor as a stator of the brake?
With the regenerative braking?
No, just have normal brakes.
Ah.
On the back.
Yep.
But have the operating on the stator of the motor. So you rotate up the motor, sorry.
No, I'm not. No, so I'm not 100% sure on how the motors actually work. So I know they're.
Look into designing your own motors from scratch, or?
No, we haven't looked into that. Edwin, who's also one of our motor specialists, he will talk next, actually, and you'll have lots of questions for him, I hope. But yeah, no, that's something we consider, but we can look into it. Thank you once again.
Yeah, just with the rear, with the brakes, so you don't have calipers on the rear.
No rear calipers at all. No calipers, no discs, no lines running there, nothing.
No brakes, just using the motor.
Just using the regenerative braking on the motors.
And that meets ADR regulations.
According to the Category B vehicle requirements.
Is there not a specific, like you've got to be able to stop in a certain
Yes. Yes. So yep. So what we've done is with our mathematical model, we've worked out what brake force we need at the front, which is obviously more, seeing as you need a front bias. The rear is less, but it's still quite significant. And yeah, it does fit, it does work, but this is also how we came about to find that the motors that we had selected initially couldn't quite give us the brake torque that we needed for the rear, and this is why we're also looking into the other drivetrain options. Yeah.
How many motors?
At the moment, on this current model, we've got 2 motors, but there is a possibility of just using 1. And we're also doing some research into other motors that aren't as easily found through Google searches. So yeah, that's something else that we're looking into. Yeah. Yeah, there could be a possibility where there is 4. So 1 to each wheel, but that's further down the track. For this version of the car, we'll get 2-wheel drive, rear wheels, and get that going first, and then yeah, possibly move to 4.
Given the history of this whole thing that we started with,
yep.
Most of those solar cars, I think, or at least the more interesting ones, used to have 3 wheels and 1 motor.
Yep.
One highly efficient motor. And yet that's not the case with this. Well, why did you move away from the 3-wheel model?
From the 3-wheel? That would be more for the general stability. Now, when I initially started on this team, it was just going to be a 4-wheel car. So as to the reasons why, the one over the other, I'm not 100% sure, but I'm assuming that's more the reason why they're going down this path as opposed to a 3-wheeled option.
Aesthetics must play a part in that.
Well, yeah, there's aesthetics, and there's also unfortunate history related with some 3-wheel cars. I'm not saying all. I'm not saying solar cars, but there are some. I'm not going to mention the Reliant Robin, but it's all right.
There's a cute American sports car, I think it's called the Torque EV or something.
Yep. Yeah, no, and I believe currently Morgan have currently released in the past couple of years another 3-wheeled version, but they've got their single wheel on the rear instead of the front, which is a bit different. Yeah. Anyone else? Right, thank you very much. Edwin's next.
Hello everyone, my name's Edwin. I'm the crazy mad scientist guy who sits in the corner with all the electronics. We had a couple of major issues with this kind of thing, the energy management. We have a lot of incoming energy coming in from the brakes because we're using a complete regenerative system for the back, so yeah, lots of energy coming in. We're very concerned about the battery life, and as many of you probably know, or have a life anyway, sorry. Lithium-ion batteries, so they heat up, they're hard to recharge, we have to keep track of them. They don't like the high currents coming in from regenerative braking, and we have that coming in every single time we stop. So we have to find a way to shield the batteries. I've been researching using ultracapacitors to supplement the batteries during high power loads. So that'll allow us to absorb as much of the energy as we can from the brakes and to also accelerate the car. Just shielding the battery from having to shove out high amps at any point, and that should increase the cycle life, or will increase the cycle life. And
so you have to capture all the energy that you generate, capture stuff somewhere through a resistor.
Because we've got regenerative braking as the primary source on the brake on the rear. To get our brake forces right, we have to potentially absorb it all. Some of it will be lost in aerodynamics and rolling resistance, but
you have to put it all in the batteries. That's what
to the ultracapacitors.
Supercapacitor for, like any excess energy with regen braking and regen suspension.
I'm saying, why even store it? Why not just throw it away?
Efficiency, like you get straight edge, you don't want to throw it away.
I was thinking, in an overall picture, if you got weight constraints and you were considering normal brakes, which don't give you any energy storage, right? And then you discard normal brakes because they're too heavy, maybe you could just throw away some of your regenerative braking.
A bank of EDLC is actually pretty light when it all comes to brass tacks. Adding a couple of EDLCs in there would be, help raise efficiency with minimal weight loss, like with minimal weight gain. So yeah.
You guys can keep talking, it makes my job really So I've been playing around with MATLAB doing different simulations on ultracapacitors and batteries and seeing how it balances out. What we found is ultracapacitors have a very low energy density, but a very high power density. So we can put out massive power or absorb massive amounts of amps and stuff, but we can't sustain it for very long just on the capacitors unless we have a rather large array. Also, they've got very low voltages with the ultracapacitors, just 2.7 volts, I think, 2.5, around there. So with the voltages we're looking at, to just below 200 volts for our DC bus, we have to have a rather large array of the capacitors in series. When they're in series, the overall storage doesn't go up. Yeah, because it's the reverse parallel resistor rule, I think. So as many of them in parallel as possible is great for storage, but horrible for the voltage. So I've been working with DC converters, so buck and boost converters, to see if we can have a rather large array of parallel capacitors with a low voltage, but to constantly just transform the voltages to be stored in the capacitor. And I just need to find out how much power we're going to lose doing that at certain areas, and we'll be fine. So the simulation results for the simulation here is we've got the ultracapacitor. I couldn't find out how to work the really big ultracapacitor block that MATLAB have because of some conversion and other issues, but I'm sure some of you guys know how to use it, so I'll be talking to all of you pretty soon. But the ultracapacitor voltage, as it discharges, the voltage goes down quite a lot along with the capacitor. So when the capacitor voltage reaches 4 volts, the system switches off. I let it switch off for a little while, and then the generator takes over and recharges them. And over here, the load voltage remains constant at 12 volts on the capacitors. So regardless of the voltage of the capacitor, depending on the energy we have there, we can sustain the voltage with the DC-DC converters. It's just a matter of calculating, again, what the losses are. So the lower the voltage gets on here, and if we want to keep the the load voltage the same, the losses tend to get a little bit bigger because the converters are doing a lot more.
So this is an obvious thought. You're going to generate the maximum voltage when you're under the maximum braking. In general driving, they're not under the maximum braking, hardly ever. So you're going to carry around all this extra electronics or weight and capacitors and things, or the one occasion in once a month that you might be your brakes are running out. That would seem not worth it. Because when you're driving, you don't use your brakes that hard. You're only going to generate a lot of energy when you stop hard.
Yep.
When you stop gently, like all the other traffic knows, you probably won't even need any of this because you can be able to take it.
Yeah.
So,
We found the voltage stays the same. It's just the amps that kind of go up and down when we're dealing with it. So the capacitors can take a surprisingly large amount of amps. But it's not going to be constant energy, so the array won't have to be that big to begin with. But yeah, you make a good point. We could reduce the weight of the whole array by dumping it in a really bad situation.
emergency situation.
Yeah. So this took me a little while to put together. If you squint, it kind of looks like a kinetic energy recovery system that you use in Formula One cars. Formula One teams like to kind of show off their results and stuff online, so it's a good benchmark to make models on and test your results to see if they actually meet the real world standards. You'll see there's a clock on there, that's a lap timer. I can actually, I've got a brake flag in there, so I can download laps from Formula One cars and see when they brake and when they accelerate, and have a bit of fun with that. But what we're looking at mainly is the amps going into the capacitors and the batteries, and in hindsight, dark purple was not a very good color to use for a presentation. But MATLAB tends to tell you what to do that way. The really large yellow spikes, those are the amps going into the capacitors. These are Formula One speeds, so nothing near what we're going to use. It's just to test the accuracy of the model. As you can see, after the main straight on the first braking turn, it goes up to close to 500 amps, which I don't think we'll see. But the purple line, which you can kind of see almost stays at 0, curves a little bit when we get there, and that represents the battery amps. So what's happening is, as soon as the car slams on the brakes, we're getting a massive spike in energy coming in. The batteries charge as fast as we allow them to, and the rest of the energy goes into the capacitors. And at the center of the turn, or the apex, or whatever it's called, they go hard on the gas. You discharge as much as we can from the capacitor using the electric motor that they've got on board, and the batteries discharge as well, again as fast as we allow them. And that's the kind of system we're planning to use to recover as much energy as we can for the solar car. So so far the model's accurate. I just need to get on all the details for our actual vehicle. And our tyres are really hard to find information on for rolling resistance, so I'm working on that. Yeah, if you can see this dark purple line, can anyone see the dark purple line?
Just.
Yeah. Okay, that's the batteries. I probably should have put units on the side, but I just zoomed into the graph.
So that's an expanded view of the
That's
top.
the expanded view. So we're looking at this point here, and that's about 10 amps compared to the 500 amps the capacitors are taking. But yeah, that's the direction we're going for the energy absorption so far. I'm going to keep working on that. Cool. Yep. Any questions?
Is that the old cars or the new cars?
Sorry?
Is that the new cars with the regen, or is that the old?
Oh, it's the first iteration.
So it's not the V6.
No. But would that make much difference in that simulation?
Well, they use different, and they use regen on the turbo too.
Oh, okay.
That's right. Yeah.
That's cool.
What they do, they heat out of the exhaust blower.
That's been a turbo up.
Yeah, I think
I'll have to try that one, but
Stop turbo.
That's awesome.
Are you handling batteries as well?
I'm not formally the head of the battery team. Their work kind of does cross over with mine.
Okay, I'm just wondering if someone who's speaking to the battery side of things.
Not tonight. What do you want to know?
capacity?
15 kilowatt hours. Lithium ion. Around, actually James is here. Hi James. What's the voltage we run the battery around?
160 to 170.
Cool. Was there anything else?
After the spike of the regen going into the capacitor, is the actual vehicle, will the actual vehicle be running the power out of the capacitor instead of the battery?
That's the plan. So once we have this energy captured, we want to use it to accelerate the vehicle after we've decelerated, to save the battery a couple more cycles.
Okay, so all the capacitors were fully discharged, in order to drive you to regen, they'll recharge you, and any excess along with the batteries.
Yes. So any excess we'll just try to trickle charge the batteries, but we'll probably keep them at a certain controlled state. If you want to accelerate while you're at speed, maybe there's some energy in there which we can use, unless we find the batteries can just take the entire load without doing much damage to them. Yeah, so we'll just try balancing that.
So does that mean that the motor controller is sized for the potential current that can come out of the capacitor?
Yeah, the motor controller we use, the Tritium Wave Sculptor 22, it can take a rather high amp load, about 122 amps. We're not going to see anything near a Formula One kind of style braking situation. So 100 amps should be plenty. And yeah. Can I go there? Good.
So my name is Barry. I'm involved in the commercialization of the car, which is the other 50% of the project. So turning these ideas into reality is very complicated and difficult. So there's not many startups actually in Australia that are multidisciplinary. There's not many startups actually attempting to do something in manufacturing when manufacturing is going downhill, particularly in automotive. So, I mean, recently, Clint and I went to the AGM of the Society of Automotive Engineers, and the whole theme of the night was, interestingly, entrepreneurship and innovation, and that engineering should involve entrepreneurship and turning ideas into reality, not like in the past, where engineers would be able to get jobs easily at large car makers. So, essentially, it took me a while to actually understand the project and the industry, and we've actually worked out a unique business model to potentially make this work. So two of the major issues with electric vehicles is, one, how expensive it is to buy. And obviously this solar car is extremely impractical, like when the mobile phone was a brick and cost $2,000. And the second thing is range anxiety, which is related to the advancement of technologies in the industry to actually increase the range of the electric vehicles. They're the two major market concerns at the moment.
So you have sunset anxiety.
Pardon?
You have sunset anxiety.
Yep. Luckily, we've got a battery that stores some energy that can drive without the sun. So basically, with those two problems, we've actually innovated in terms of the business model. Firstly, we've actually worked out that we can actually sell these cars in low volume globally from day one under a custom car model. We've been in talks with various car builders, custom car builders, and they're very keen to have us on board. We're only aiming to sell about 5 to 10 cars per year globally to the consumer, which I don't think is impossible if you look at the maths. For early adopters and people who have a high net worth, personally. Second people we can potentially sell to is corporations who are looking to promote social sustainability, environmental sustainability, social responsibility. And there's lots of corporations like that in the world now, with Europe recently increasing the laws and strictness on corporations involved in this space, and they actually role in terms of protecting the environment. The second report is the UN is actually saying fossil fuels is not viable for the future and that we need to focus on renewable energy. And the third report from Deloitte has said that one of the growing industries in the future is actually solar technologies. So in terms of the second part of the business model is the car will act as a technology platform, an IP bank that will potentially allow parts of our car that various industries, including automotive, are interested in terms of licensing the technology and actually improving some of their processes currently they need. So essentially we'll probably exist as an R&D company for larger companies, which involves licensing and potentially spin-off companies which may create new niche advanced manufacturing companies in Australia related to the parts and OEM industry, which are looking for different alternatives to their problems that they'll be facing in the next few years. And so in terms of progress, we've actually became national finalists in a Silicon Valley-based venture accelerator out of thousands of applicants, and we actually pitched the idea to them, and we got into the top 6, and they said the actual model was viable. Second thing is we're getting a lot of PR. Have you heard of Beyond Emissions? Beyond Zero, the radio station. We're on that, which is quite an achievement for a startup. And we got a bit of exposure from that to Ford Motor Company, who are actually interested in our spot cooling technologies and the regenerative suspension. So, which is great news for us. The third thing is I was invited to do a TEDx conference speech about this, but I think it's a bit too early to do it because we want to get the exposure at the right time when we're ready to, tell the world about it. We're still a bit early in that. Most people misconceive our startup as a mass car producer, so they sort of just fob us off, but we're not that. Essentially, we're going to only sell 5 to 10 cars a year and license off the IP to different companies in our space to help out local manufacturing as well. And recently, we also got on board an electric scooter company that transports cargo for food locally and potentially globally. And there's actually sharing of IP or potential leverage of IP in our technologies as well. So that's just proof that we're slowly getting somewhere with this. The last thing is one of the Docklands Council are developing a public transport ferry service between Docklands and South Bank. And we've partnered up with a boat builder there who's looking into hybrid or a pure electric ferry product that will be a public transport system, which may relate to the use of some of our technologies as well. So that's where we're at with the project, and we're currently finishing off the business plan, which is an enormous task. And we've already got keen investors who have visited Swinburne to have a look at what we're doing. So the idea is there, and the second thing is we've actually got interest overseas already from Malaysia in someone who likes our design and wants to buy the car. So I think it's positive so far, hopefully.
So I want to talk about, so if you were to pick a traditional car manufacturer, or even Tesla for instance, would you say you're looking around like the Lamborghini style tools you're modeling around this? I mean, talking about top end market and also specialised engineering that is going to use to look at any of those particular models to
Yes, actually, that's a very good question because McLaren have just released a P1. Have you guys heard of that? And Porsche have released their supercar as well, and they both have electric. They're both hybrids. So if we just have one of these technologies that actually perform, pardon?
Picked up by one of those companies?
Yeah, but picked up by just one of these technologies in our car that's picked up by one of those companies because it takes them so much time to get there. We're onto something already. So yeah, so your question is correct. In the supercar class, they will probably be looking at some of our technologies because they don't really have the time to R&D and test the product. So if we can actually get this road going on the road, then we've actually done the 80% for them.
Where's your target market?
So the target market so there's two models. So it's actually a business-to-business model, which is the technology platform, and there's a business-to-consumer model, which is the car. Our target markets for the car at the moment are finding very rich people internationally who just collect cars, who are relatively educated, generally have an idea of sustainability, and the risky ones who are early adopters to technologies. So we're not looking at someone who are the conventional type who want the airbags.
You also mentioned groups or corporations or whatever.
Yes.
In that space.
Yes. So potentially banks or different larger companies would probably drive this around as like a dynamic sign, and I think it would attract attention for them.
What sort of timeline are you looking at to basically first line?
So as soon as we raise the amount of money, basically we're ready to build the prototype. So we're looking between about 6 months to 12 months in terms of raising money, but we're focusing on the local market first, but it's unlikely that we'll get the majority of our investors in the local market, which means we have to look overseas. And then after that, the car will pretty much be built between 6 to 12 months.
Does that include validation, or is that just to do work with
pretty much validation as well. So we'll be able to, as soon as we build the prototype, we'll be able to take pre-orders from people, and then with a bit of testing, when we have the prototype, we'll be able to actually build them and adjust some of the things the engineers have done to actually build the car to roadworthy specs.
What sort of capital do you need to do the prototype?
About $750,000. It's not that big actually. Tesla actually, it cost Elon Musk to build his first car, which failed, which was like on a Lotus body, $6.5 million. Because the difference with him is he idealistically went for the mass market with all the airbags and stuff, but we're not looking at that model. We're looking at the ICV space, which is basically a road legal version of custom cars that people use for weekenders. We're not looking at a daily drive at the moment, but we think over time that these things will probably become in mass production. It may not be our company, maybe somewhere in China or something like that. We don't know. Most likely.
You have to crash test one.
So what was that?
Crash test?
No, as long as we meet ADRs.
Yeah. As long as we meet all the regulations in Australia, which are relatively strict to the rest of the world, we're okay. We're okay.
But isn't there a limit on how many MOCVs you can actually construct for the same thing? And when you get above a certain number, then you have to qualify?
Correct, that's what we're looking at 10 worldwide.
Yep, so we're looking at partnering up with local custom car builders in different parts of the world as well to actually address that regulatory issue.
What sort of percentage of your income you're looking from your business to business models compared to your business to consumer?
We've actually, would you have to bring up the...
I don't have that here, sorry, but...
we actually modeled this on a probabilistic analysis design. Clint's actually got a PhD in it, so you can explain a bit more.
Essentially, though, the car should be paying for itself, breaking even, and the return on the investment is going to come from the IP. That's essentially the way the model's looking. One of the things we do want to do that hasn't been mentioned here is we want to really reward the custom car builders. Well, the custom car builders gets, if you get a custom car built, the guy who built it for you probably not getting a lot out of it. So part of our model is to make sure those guys are well rewarded so that they want to inherit the car as well. And that's something we can do having the IP avenue.
I think the IP from the shock absorber would be, I mean, there's a lot of shock absorbers in the world.
Yeah. Well, because Ford sent us an email, after listening to that interview, Ford sent us an email.
Yeah, after the radiative.
And all the work on hydraulic fashion isn't the electric pumps, like our gentle electric. So pure electric is something.
And yeah, the regenerative suspension has application in different industries as well, like gyms, for example. There's actually a company in the UK who have probably, hopefully not as good technology as us, but on treadmills. So when people run, it actually saves money on the whole actual gym. So, and the other one we were looking at, yeah, so they get carbon credits or something like that when they run.
Muscle tone and carbon credits.
Muscle tone. And the other one is boats at night. So if you have a solar boat, for example, rocking at night will charge the boat overnight. The other one is bridges, like the sway. So there's actually lots of different applications that we haven't explored deeply at the moment that the regenerative suspension has.
I think we can find that the spin-off is much bigger than the car.
That's the plan.
Yeah.
Yeah.
Yep. So yeah, that's where we're at, but it's very exciting.
How far off do you think the first car will be to be built?
I'm not a psychic, but
I knew you were going to say that.
I'd say probably within the next 1 or 2 years. Hopefully we'll have something at the International Melbourne Motor Show.
Nice.
Yeah. And we've already got contacts in that. We've got contacts at Formula 1 as well, via Aurora. So if we get to that stage, then we're going to make history, really. Our team's going to make history.
The other companies then just push a show in there. It's got no wins in it. Like Ford Holland or whatever. You know? The car of the future.
Yeah.
Jacob, is your preference to launch in Australia, in Melbourne, or are we looking overseas?
Well, John, you probably prefer it to be launched in Melbourne, right?
Absolutely.
Well, if we well, according to Wiki, we are the manufacturing capital of Australia. So if we can actually do it, ideally in Melbourne.
Not Geelong?
Geelong, Victoria.
Sending a message out
because we're going to have a lot of we've got a lot of industrial space out there when Toyota and Ford and the rest of them close. So if we can do something here, then there'll be a massive social reward for us as well, on top of the financial. But we've actually found the balance between the two, that we get that social impact, and also potentially the economic benefit too.
Sorry, have you spoken at all with the Victorian government in relation to the growth fund that's currently being discussed between Ford, General Motors, Toyota? It's potentially something that maybe I'm tapped into. I suppose it's so the growth fund is the money that's being made available to a number of engineers and manufacturing workers that are going to be done in the next 5 years.
Is that the one in Broadmeadows? Like, is like something related to the
So it's a combination. There was originally there's about I think $60 million was pledged from federal government.
Yep.
Then another 15 from state, and then I think Holden were asked to chip in $1 million roughly.
Yeah.
So,
yeah.
I think the money is primarily targeted at transitioning people out of automotive manufacturing into similar or different industries.
Yeah, I've heard about that, but to be honest, I haven't investigated deeply. But one thing I heard is Ford Australia, because they recognise that we have really good engineers here, they're looking to build an R&D collaboration company here in Australia for the future of their division here, which is a good sign, which means we probably have relatively smart people.
I suppose the point I'm just highlighting might be something that's a benefit to you if you were to approach the government. Like,
yeah, well,
I'm a worker in the automotive industry. I'll be out of work fairly shortly. There's probably at least 500 other people in the same boat as myself.
Yep, and that's
one of the reasons why I'm here tonight, because I've heard that there was a startup company that was presenting and just pricked my ears.
no, thanks for coming, because we're actually also, SolarX itself, as I said, it's a company that's not just involved in the car. We're looking to create a co-working ecosystem for engineers in the automotive industry that are interested in electric vehicles. Like, we've got actually a few people here listening as well, with new inventions, new innovations that we can help commercialize. And that we're actually looking to the property component of that at the moment, because we actually realize there'll be a massive amount of automotive engineers who will be unemployed in Australia, and many of them have really good potential IP. With the right know-how, would be able to actually make a new career out of it too, and be of benefit to the rest of the world and the automotive industry. So, and the EV space is amazing. I mean, you guys probably read it because you guys are all into this type of area, but the actual sales of EVs is increasing almost like very fast, and the only thing at the moment that's limiting is the battery. But that's changing as well. And also Australia, I think in 15 years they were saying the market research report says Australia only has about 1% market share of the whole EV market. Most of it will be Japan, China, and the US. So essentially Australia needs to be in the niche manufacturing or advanced manufacturing area and be in IP, which we've shown in other areas like medicine as well. So I think there's a future for engineers like yourself here with the right communities and culture and grants. Yeah.
Any questions?
Any more questions?
Can I just ask a really silly question? BlueScope Steel have got a technology where they're actually putting solar panels directly onto steel. You know, like you shed out the back, they're going to be able to they just put solar as a sheet of metal. I don't know whether you're looking at that, and Melbourne University have got some technology where they're just putting solar panels on plastic and printing them off. So that might be something.
Yeah, no. Is that in Australia? Are they doing that in Australia?
Melbourne.
Melbourne. Oh, Melbourne. Ah, that's great. So.
A lot of those technologies are low output, so they can put on large. They're inexpensive to put on large roof areas. You're constrained in space, so you need really high efficiency. Yeah, in solar technology.
They might be able to take that technology. I mean, they've got the technology.
In the future,
yeah,
useful. And can't say right now. They'll be technology.
Yeah, they're typically both.
So current. You can't. It's like they're right. It's like solar panels. There hasn't been a lot of inroads in efficiency. The ones with efficiency. Once those they've got ones
So, any more questions from the floor?
One of the main things about that is because we're actually developing solar panels on a moving object, there's an association with that and how the solar panels keep cool and how it's mounted on. So that there may be applications for that for a dynamic object like a boat or, I don't know, a truck and things like that. But in terms of the static side, I'm not sure. Maybe. Any other questions?
Any questions? No, I just want to say it's a really interesting talk. Quite a team of people doing something revolutionary here in Melbourne. That's pretty exciting, and wish them all the best. And if anyone's got any good ideas to pitch to them or any other things, I'm sure that they'll be like big sponges soaking it in. But these guys put a lot of work in. It's fantastic. So let's call the meeting to a close. Go and have tea and bickies, and you can pick these guys' brains a little bit more, and hopefully fertilise our EV minds. Okay, thanks.